and good evening to everyone. My name is Mark Oliver Dipasubi,
I'm John Mark Junisha.
And I'm Justin Medina.
and tonight we are going to discuss our plan for installing a grid-tied solar power system to our home. So first, let us discuss our objectives. So first objective is to discuss each component that builds up a grid-tied solar power system. So ano ba yung mga parts na kailangan ah, na i-install namin para makabuo ng isang grid-tied solar power system. And pangalawa is to devise a plan or yung makagawa ng plano para yung magkaroon ng zero bill yung grid-tied solar power system namin sa bahay. And last is yung para i-calculate yung mga necessary ratings of each components that will make up our solar panel system. So, okay.
So, what are the types of solar power configuration? So, first we have the grid type. This type of configuration directly connects your solar power system to the electric grid. This does not use any battery. So, itong grid type na to, yung solar power mo or yung buong system mo, nakakonekta pa rin sa control panel at yung control panel nakakonekta pa rin sa sa distribution utility nyo. So, dahil nga wala itong baterya, ibig sabihin, dito gumagana sa gabi. Kumukuha ka pa rin ng kuryente sa mga panahon na yun sa distribution utility paggabi. Upgrade. This configuration powers your home and changes its battery during the day and will be relying on that charged battery during the night. This configuration is completely independent of the grid. So parang kabaligtaran naman ng itong upgrade dito sa grid type kasi ito naman hindi siya nakakonect sa purely dependent siya sa sarili niya. So wala kang bill na makukuha na may power bill ka kasi nga ikaw na nag-generate sa sarili mo. Tapos during the day, pag nag-generate na ng enough na charge yung battery mo, eh doon siya magre-rely para sa night time kasi walang araw doon sa panahon na yan. And ano naman yung hybrid, similar to the grid type, this system is connected to the electric grid, but this configuration includes the use of batteries as well. This addition of battery will help during power interruption or brownouts where traditional grid-tied system is ineffective. So parang mix naman to ng upgrade sa grid type. So yung solar power system mo nakakonekta pa rin sa electric grid nyo, pero at the same time meron pa rin kayong battery in case na magkaroon nga ng power outage. So parang mix siya ng dalawa. Ngayon, magpo-focus tayo sa grid-tied solar power system. So it is a system which uses solar panels to produce energy while also being connected to an energy distribution utility. So katulad nga ng sinabi ko, nakakolekta pa rin siya sa electric grid kahit na nagpuproduce siya ng sarili niya. This system does not have a battery, meaning that it won't work during the night. It also does not work during brownouts or blackouts. So ito yung sinabi ko, meron tong electricity kapag merong kuryente sa electric grid o kaya naman may araw. Pero pag wala yun, magre-rely siya sa mismo electric grid lang. Yun nga lang, pag nagkaroon ng blackout, yun din, wala rin magkakaroon ng kuryente sa iyo. Kasi nga, pati yung electric grid mo, wala rin kuryente. At dahil wala rin baterya, ibig sabihin total blackout din sa inyo sa panahon na to. So, kapag may excess energy na produce ang solar panel mo, hindi yun kung saan lang mapupunta. Makakontribute yun sa energy bill mo in a way that i-reduce niya kung ilan yung na-generate mo sa nagamit mo. So, sabihin natin may 100 kilowatts kang na power bill. Tapos ang na-generate mo naman na sa solar panel mo is 80 kilowatts. Ibig sabihin, 20 kilowatts lang ibabayaran mo dahil na-contribute yun ng excess energy na produce ng solar panels mo. So, ito yung grid tie diagram. Panels. So, dito yung DC circuit breaker. Slot ng DC current or direct current o pupunta sa inverter, convert niya yun sa AC or alternating current. Tapos, dadaan yun sa control panel. So, components. So, of course, meron tayong solar panels, grid tie inverter, with or without limiter, modified or pure sine wave, DC and AC circuit breaker, DC and AC SPD, time delay switch, and programmable time delay switch, MC4 connectors, solar rail, DC-AC electrical wires.
Solar panel. The heart of solar-powered home. A typical solar cell will only produce around half a volt. So by connecting them together in series inside the panel, a more useful voltage is achieved. Most small solar panels, rated 150 watts or below, are rated as 12 volts, while larger solar panels are 24 volts. A 12-volt solar panel produces around 14 to 18 volts when put under load. This allows a single solar panel to charge up to 12-volt battery. Incidentally, if you connect a voltmeter up to a solar panel when it is not under load, you may well see voltage readings up to 26 volts. This is normal in an open circuit on a solar panel. As soon as you connect the solar panel into a circuit, this voltage level will drop to around 14 to 18 volts. So sinasabi daw dito na sa isang solar panel ay binubuo siya ng cells which produce only around half a volt. So by connecting those cells in a series connection, nagpo-produce daw siya ng much more useful voltage na ginagamit natin sa ating circuit.
Okay, so ito yung top 3 brands na aming napili, which is yung Trina, and LG and Jikto. So note that all these brands can also be bought online. So, okay, next. So, first is the Trina Solar. So, Trina Solar is one of the leading manufacturers of PV cells, producing top tier or yung top tier 1 solar panels in terms of quality and durability. Aside from its reasonable pricing compared to other brands, it offers excellent warranty services to ensure the product overall longevity, all the while having top-notch performance. Tina is the go-to brand for those who are seeking for long-lasting functionality and high efficiency. So, ang Trina, ang pinaka, tawag dito, pinaka-forte niya is yung kung gaano tatagal yung solar panel. So, bukod sa matibay na, sobrang haba pa nung warranty service niya. So, umaabot siya ng up to 15 years yung warranty. So, i-ensure nun na tatagal yung system mo for a very long time. So, baka pwede pa siyang maabutan ng apo mo pag ito yung ginamit mo, solar panels. So, next brand is LG. So, yung LG narinig na natin sa ibang products yan, no? So, hindi lang solar panels. So, LG is one of the most prominent names in the electronics industry. So, yun yan. So, it's no surprise to us when they also begin in the solar energy scheme. So, LG solar panels provide high efficiency as well as durability, and is mostly the best overall in many reviews. So, LG daw, so in terms of overall na quality, ito daw yung pinakamagaling. Kung gaano katibay, kung gaano tumatagal, so kung gaano niya na-release yung wear and tear, and yung talagang overall na efficiency niya. So, very high efficiency. Yun nga lang, fortunately, after 30 long years, they decided to shut down their manufacturing of solar panels due to the pandemic. Okay, so ayun. So yung downside. So bigla nagsara. So meron pa naman sa market na mga LG solar panels, kaso nga lang, yung mismong LG, hindi na siya nagpo-produce. So, over the years, since pakunti yung solar panels, nagmamahal din siya. So, yun, downside. So next na solar panel na napili namin is yung Chico. So bakit bakit ito yung top 3 namin? So Chico solar panels are currently ranked in the PV Evolution Labs top performers over 4 of the 6 annual tests and are now one of the few manufacturers that have consistently been listed as top performer for the last 6 years. So yung Chico solar panels, ito siyang Chinese brand. So alam natin na yung Chinese ang China yung isa sa mga leading na nag-produce ng solar panels. Isa sila sa mga leading countries pagdating sa solar energy technology. So yung PV Evolution Labs na to, ito yung parang annual na ginagawang test para makita kung aling brand yung pinaka high quality. So yun, parang yun nga, 4 of the 6 annual test. So ito yung Ginkgo daw yung pinakamataas sa 4 na nag-test for 6 years. So yan. This is a good indicator of them being able to solve the industry. So yan. So ayan yung tatlong solar panels na napili namin and why are they our top 2. So ito yung mga stores na napili namin na available yung mga products na to. So first, yung Trina Solar Angeles. So sa Angeles, matatagpuan ito sa Angeles City, Pampanga. So yan. Address name is Bongtang Avenue, Balibago, Angeles, Pampanga. So yan. So dito sa store na to is makakahanap ka rin na Solis inverter. So pero mamaya natin i-discuss yan. So, location 2 is yung Ian Solar Energy na matatagpuan sa Caloocan, Metro Manila. So yung Ian Solar Energy, marami ding branch ng solar panels at inverters sa makikita dito. Most prominently yung Solis. So yung Solis mamaya. And location number 3 is yung Wicon dito. So yung Wicon dito is nationwide, marami siyang branch. So, hindi lang siya sa Baliwag matatagpuan. Meron din siya sa Gapan and Cabanatuan. Okay? So, ayan yung mga locations kung saan kayo pwedeng makabili ng solar panels and inverters.
Solar panel connection. So, there are 3 types of connections. First, the series connection, the parallel connection, and last we have the series to parallel connection. So here we have the series connection. So makikita natin na meron tayong 4 na panels connected in a series. So to compute the output of these 4 panels, so first we have to identify the voltage, which is we have here for every panel we have 12 voltage per each. Then to compute yung complete voltage na itong 4 na panel natin, pag-a-addin lang natin silang 4. So we have 48 volts. And yung ampere natin is constant. So to compute yung power, we just have to multiply volts and current. So ang lalabas na watts natin, na power natin is 240 watts for series connection. So next we have the parallel connection. Dito naman sa ating parallel connection, ang magiging constant na value natin ay yung volts. So meron ulit tayong 4 na panels. Then to compute dun sa power natin, i-identify natin yung current natin, which is 5. Then we just have to add. We have to add them, and we will get 20 amperes. So para i-compute yung power natin, i-multiply lang natin ulit yung volts dun sa current, and we will have 240 watts. And lastly, we have the series parallel connection. So here, makikita natin na yung 4 na panels natin ay connected sila as a series and parallel. So yung dalawang cell sa kabila, sa pag-compute ng kapag series ang connection natin, pag-compute ng voltage natin, since dalawa silang connected as a series, meron silang 12 volts each. So magkakaroon tayo ng 24 volts. And then the other connection ng parallel naman, para i-compute yung current natin doon, which is 5 each. Meron silang 5 each na current. We just have to add them to and we will get 10 amperes. Then to compute yung power ng apat na panels natin, pag multiply lang natin yung nakuha nating total ng volts and current, then magkakaroon tayo ng output na 240 watts. So mapapansin natin na kahit anong connection ang gamitin natin, iisa yung output na kakalabasan. So sa pagpili naman ng gagamitin nating connection sa pagkakabit ng panel, depende na dun sa magkakabit yun kung ano yung preferred niyang connection series. Sorry.
So, for the solar panels, meron tayo dalawang types, monocrystalline and polycrystalline. So, from the name itself, alam na natin kung ano yung sabihin. Pag mono, one, poly, marami. So, una yung silicone arrangement. So, alam natin, yung solar panel is, ang pinaka-main component niya is yung silicone. So, yun yung pinaka-semiconductor niya. So, sa isang monocrystalline na solar panel, yung gagamitin na silicone na semiconductor is, kumbaga, isa lang yung hindi siya fragmented. So, parang isang piece lang siya. Isang piraso lang. So, unlike dito sa polycrystalline, is para lang siyang maraming fragments ng silicone na pinagdikit-dikit or pinag-melt together. So, yun. Kaya, sinabing monocrystalline and polycrystalline. So, sa cost, ano yung pinagkaiba? Yung monocrystalline, more expensive. So, kasi isang piraso lang. So, oo. Unlike dito sa polycrystalline na less expensive kasi pira-piraso lang siya na pinagdikit. So, sabihin natin na parang recycle lang yung mga pinagtabasan na monocrystalline. So, yun yan. So, appearance. So, paano ma-distinguish kung which is which? Yung monocrystalline, usually meron siyang black na kulay. Kulay black yung panel. So, yun naman polycrystalline is kulay blue. So, yun yung pagkakaiba. So, pag bibili kayo ng solar panel, para malaman nyo kung monocrystalline siya o polycrystalline, yung mono, pero kulay black, yung poly, kulay blue. So, yun yung pagkakaiba sa appearance. So, efficiency. Yung monocrystalline, more efficient siya. So, kaya mas mahal din siya. Yung naman polycrystalline, less efficient siya kumpara sa monocrystalline, pero less expensive siya. So, yun yung pinagkaiba. So, naging more efficient siya kasi nga isang buong piece siya na silicone. Unlike dito na pira-piraso na, so syempre, pag pira-piraso yung semiconductor, nagkaroon ng para, sabihin natin, impedance sa pag-performance niya sa pira-piraso. So, gano'n naman tumatagal yung bawat type. Yung monocrystalline, tumatagal siya ng 25 to 40 years. Ito naman polycrystalline, tumatagal siya ng 20 to 35. So, mas mahaba yung buhay ng monocrystalline. So, temperature coefficient. So, yung monocrystalline, meron siya low temperature coefficient. Meaning, mas tumatagal siya sa init, sa mga hot climates. So, ito naman sa polycrystalline, meron siyang high temperature coefficient. So, making them less efficient. So, in conclusion, mas preferred ng marami yung monocrystalline for its efficiency as well as dun sa temperature coefficient. So, ayun, yung types ng solar panels. So ito yun, yung tsura ng tawag siya. So yung monocrystalline kulita, like I said earlier, and ito yung polycrystalline.
So, sa inverter naman, usually makakita ka ng either ganitong type or ganitong type ng inverter, no? So, usually, kung i-judge mo yon, basically, same, ano lang naman sila, same function. Usually nga lang, sa mga ganitong type, mas may additive sila. Sabihin natin na, ano, may wifi, ganun. Pero, ang main point lang naman nila is dapat nag-invert sila ng DC. So, kung gusto mo mag-prices, siguro sa mga ganitong itsura yung gusto mo. Pero at least mas maganda siya tingnan. Kaysa dito sa parang isang malaking ano lang, power unit lang. So, sa inverter tayo ulit. So, inverter is a device that lets you convert DC to a more uniform alternating current. So, uses a semiconductor components such as MOSFET to switch the direction of the current to get an alternating effect. To make it simple, imagine these semiconductors as a automatic electronic switches. Some solar panels have a built-in microinverters, so mga panibago to, no? Mga new inventions lang. In them that automatically converts DC to AC. However, it is not suitable for systems with batteries. So sabi nga, no, merong solar panels na may built-in siyang microinverters, kaso nga lang di ba merong mga solar panel connection katulad ng off-grid na makonekta yung DC mo or yung solar panels mo sa batteries. So, hindi pwede yung types ng solar panel to kasi AC yun. Pag nilagay mo sa battery yun, baka masira yung battery mo. So, sa grid tie inverters, automatically silang siya shutdown kapag may power interruption or may blackouts. Katulad na mentioned last time, dahil na wala siyang baterya. So, pag mayroong power interruption, mag-feed yung nag-generate niya sa grid. Dahil na wala namang kuryente sa grid. So, parang ano lang yun, magiging excess lang yun. So, ito yung parang diagram ng inverter. So, usually makakita ka ng 4 switches. 1, 2, 3, 4. Tapos merong load sa pinapagitnaan nun. So, para ba gumagana yan? So, yun nga, may 4 switches dito. So, sabihin natin S1, S2, S3, at S4. So, paano natin masisimulate yung alternating current sa load na to? Di naman pwedeng ditong direction lang tayo, ditong direction. Kasi nga, dito lang magiging isa lang yung flow ng current. So, sabihin natin na kapag yung S1 sa S4 nakasarado, tapos yung S2 at S3 na switches nakabukas, simulate na current siya, dito dadaan yung current. So, parang pumunta dito yung flow ng current. And pag naging open naman yung S1 at S4, tapos naging close naman yung S2 at S3, dito naman yung pupunta yung lalim ng current. So, masisimulate mo na pwede mong dumaan dito yung current, tapos biglang dadaan dito yung current. So, paano nangyayari yun sa pagtingnan mo sa isang oscilloscope, I mean. So, parang ganito yun. So, di ba itong kulay blue na to, ito yung parang perfect sine wave or pure sine wave. Sa inverters, tinatry nyo i-simulate yun by pulses. So, sabihin natin mas maliit yung value, dito maliit pa yung value niya, parang small pulse lang siya. Pero gradually, habang pataas ng pataas yung value ng pure sine, mas mahaba yung duration ng pulses niya. And masasabi mo para itong square wave. So, habang pag dito sa gitna, mix na yung, makikita mo na parang makapal na yung pulses niya. So, parang pag tinignan, parang siyang square waves. Pero pag kinuha mo yung average niya, parang magiging ganito yung sine wave niya. Parang siyang ladderized. So, ito yung tinatawag na modified sine wave through pulses. So, parang ganyan, no? Modified sine wave. Yan yung para siyang laddering or para siyang square wave. Ngayon na naman din yung pure sine wave. Ito yung mas smooth talaga siya. So, ano pinakaiba ng modified at pure sine wave? So, yung modified sine wave, In pure sine wave inverters, the AC power produced by the inverter very closely matches an actual sine wave. In modified sine wave inverters, the polarity abruptly switches from positive to negative. When looking at the wave, it has stair-step square pattern where the polarity is flipped back and forth. The choppy wave can negatively affect more delicate sensitive equipment. So, kung yung output mo lang naman or yung load mo lang naman is something like lights, pwedeng effective na gamitin mo na lang yung modified sine wave, makakatipid ka pa. Pero sabihin natin mas sensitive yung sistema katulad ng computers, TVs, mga ganun. Hindi pwedeng modified sine wave kasi nga choppy yung wave niya at usually hindi maganda yung output or minsan nakakasira pa ng device yun. So if you have medical equipment need to power such as CPAP machine, mga hindi sensitive, pwede mong gamitin yung modified sine wave. Additionally, in many cases, so sasabi nga dito na pwede mong ma-distinguish yun kung modified sine wave ba siya o hindi dahil sa tunog. Pag modified sine wave siya, para siyang may hum o kaya parang may ingay na constant ingay na may ganun. Sa pure sine wave ko lang ganun. Para kasi yung nagsiswitch na sa loob ng sine wave. Eh sa pure sine wave yung makikita yun. So, isang advantage lang ng modified sine wave is that mas mura nga siya kaysa pure. So, ano ba yung pure sine wave? This type, output voltage in the form of sine waves. Utilities also provides the sine wave output. So, sa mga electric grid, ito yung pinoproduce nila. Because of this, pure sine wave inverters are usually needed if you're going to be tied to the grid. At para mag-match yung wave mo sa wave ng electric grid yun. So if you're going to be tied to the grid, so typically you'll need pure sine wave inverters for sensitive equipment. Kung sabi ko, mas sensitive siya, no? Mga TVs, gano'n. Mga AC motors, so pwede rin naman computers. So pure sine wave inverters are capable of producing cleaner, smoother, quieter, and more reliable electricity to operate appliances and electronics without interference. So paano ba natin na iba yung pure sine wave sa modified? So to recap yung modified para siyang staircase, so para siyang squares. Yung pure naman para siyang smooth sine wave. Pero meron ba tayong chance na yung pure sine wave, yung modified sine wave, pwede natin gawing pure sine wave? Actually, yes, pwede natin gamitin yun. Kung pwede natin gawin ng filters, pero usually hassle yun, tapos hindi cost effective. Mas maganda na bumili ka ng pure sine wave na inverter to begin with. Lalo na mas efficient yun at syempre mas safe sa mga electronics mo or sa load. So ito naman yung inverters with limiters. Pag mayroon kang inverters with limiters, usually meron yung parang port or slot na i-connect mo dun sa control panel mo. Ngayon, para saan ba yung inverter limiters? So kapag naka-net metering ka, syempre pag nagpo-produce ka ng power, pupunta yun dito sa metro mo, dumadaan din sa sub-meter mo. Pero kapag di ka naka-net meter, minsan dumadagdag pa yan. Sasabihin natin may 100 kilowatt kang bill. Tapos may na-produce ka sa solar panels na 10 kilowatt. Dadagdag pa yung 10 kilowatt na yung sa bill mo imbis na mag-reduce. Pero kasing mga metro na o kaya may mga sub-meter na hindi ino-contribute yung reduce mo sa grid tie na usually nakakahinder pa o kaya naman nakaka-add pa ng burden kasi nga mas dumadami pa yung power bill mo kaya sa pag-reduce. So, paano nasusolusyonan yun? Sa pag-apply ng net metering, papalitan yung sub-meter mo sa compatible na imbis na unidirectional lang siya or isang direction lang yung pupunta yung niya, yung watts niya or yung pag-count niya sa watts. Sa pagpalit sa net metering, kinakount niya rin kung ilan yung pinoproduce mo na napupunta sa grid. Pero paano pag wala kang net metering na sub-meter? So, meron pa isang paraan. Yung isa naman, yung itong internal limiter or yung mga inverter na may limiters. So, itong limiters na to, automatically, pipigilan niya yung kilowatts or yung watts na napoproduce mo kapag di naman kailangan. So, alam niya yung kung ilang watts lang yung kailangan mo. So, effective to para sa mga uh, system na wala silang sub-meter na compatible sa net metering. Inverter limiters. There are some inverters with internal limiters that prevent excess power from being delivered to the grid. So, katulad ng sinabi ko, pag may excess power kang na-produce, tapos napunta sa grid yun, tapos hindi prepare yung submeter mo sa net metering, madadagdagan pa yung power bill mo. So, inverters, alam niya lang yung ilan yung, kung gaano karami or gaano kalaki yung watts na ginagamit mo. So, nililimit niya yung sarili niya para ito lang yung kaya mong i-produce, para yun lang yung kaya mong gamitin. So, hindi prevent niya yung additional na power bill na yun. So, highly recommended or required to sa grid-tied solar system na wala pang net metering or hindi pa compatible sa net metering yung sub-meter nila. So, inverter brand.
So, these are the top 2 brands of inverters na napili natin. So, first, Solis, Solax, and then Promuse. And again, all these brands can be bought online. So, hindi mo sa mga physical store. So, first we have Solis inverter. So, ano yung mga pros niya? So, high efficiency, versatile, user-friendly, and compact. Solid inverters are designed for the purpose of convenience. They are easy to use, complete with user guide and easy to understand devices, suitable for many applications such as residential and industrial use, and is very safe and compact, capable of fitting in a small space. So, ang pinaka-forte ng Solis, ito yung isa sa mga top difference namin, is very convenient sa gamitin. So, hindi siya yung sakit sa ulo na aaralin mo pa ng ilang araw bago mo magamay. So yung ano niya, pag napili mo siya, meron siyang complete siya ng user guide na madaling intindihin and very versatile din siya. So, pwede siya sa residential and industrial use. So, pwede siyang sa bahay, pwede rin siya sa mga mall, sa mga other infrastructures for work, gano'n. So, pwede siya basta sa industrial use. So, yun. Versatile siya. Pwede siyang gamitin sa iba pang hindi lang sa home. So, user-friendly kasi nga, sabi ko kanina, madali siyang intindihin, very convenient gamitin, and very compact. So, very lightweight din siya. So, hindi ka mahihirapan na hanapan siya ng space kung saan mo siya i-store. So, very compact. So, yun. So, again, yung Solis is very convenient gamitin. Kumbaga, very economical. So, yun. So, next brand is the Solax, SolarX Power. So, ano yung important ng Solax? Yung brand natin siya napili. Affordable. Lots of variety of products to choose from, recommended by experts and long-lasting. So SolarX offers a wide variety of inverters to choose from. So you won't have to worry about not finding the right inverter that is suitable for your system. Aside from that, solar inverters are very affordable and offers great performance as well as a long-lasting time. So, yun. So, ano naman ito is very long-lasting siya. And marami kang pagpipilian. So, hindi ka mahihirapan sa pagpili mo na yung sa swak sa system. So, sabihin natin meron ka 700 watts. So, meron ka rin meron 700 watts na total na power ng yung solar panels. So, meron din sila na suitable sa setup mo. So, yun. So, hindi ka mahihirapan sa pagpili. And recommended din siya ng experts. So, meaning na maganda yung quality niya. So, matibay na and very efficient pa. And also, mura, affordable. So, yes. The last is the Promuse inverter. Una, versatile, katulad sa Solis, marami ding product sa pagpipilian, long-lasting, high compatibility, and best in overall. So, Promus is highly regarded in the solar world and generally considered the world's leading string solar inverter manufacturer. This reputation is not based on sales value, but service, quality, and most importantly, yung reliability. So for the system, this inverter is usually paired with Jinko solar panels due to their compatibility. So yung important ng focus, yung high compatibility. Pero best siyang ginagamit along with Jinko. So overall, Cronus is the best in efficiency and longevity. Ay. So ayan yung napili namin top 3 brands na inverter na gusto namin gamitin sa aming solar power system or yung grid type. So ito yung mga locations kung saan makakabili ng inverters. So again, yung iyan, nabanggit ko kanina, matatagpuan siya ulit sa Metro Manila, Caloocan. So sabi ko nga kanina, yung iyan, solar energy, hindi lang inverters, kundi meron din mga solar panels and other components na mabibili ito. So yan. So sabi ko rin kanina na yung iyan solar energy is ang pinaka nire-recommend din ng brand na inverter is yung Solis. X, again, yung Wilton Depot. Hindi lang sa Baguio matatagpuan, pero din sa Gapan and Cabanatuan and other parts of the Philippines. The location tip is yung Solax. So yung Solax, matatagpuan siya sa Makati, Metro Manila. So sa SolaX, so dito makikita yung SolaX inverter na na-discuss ko na. So dito yung mabibili yung mga nabanggit kong solar panels and inverters. But again, sabi ko rin kanina na meron din naman kayo makikita nito online. So inquire lang kayo sa mga binigit kong shops para makahanap kayo ng hinahanap ng components. So, yun.
Circuit breaker. Circuit breaker is a protected device that uses a material, usually materials that expands or shrink depending on its heat, that trips or opens the circuit to avoid damage in overall system. So, alam naman natin in general na ang purpose ng circuit breaker is to prevent the unwanted currents or yung overcurrents na ma-damage yung mga appliances na na-connect dun sa ating circuit. So, dito ipapakita natin yung reasons na kung bakit nagkakaroon ng overcurrents. So first, meron tayong high current or yung overload or short circuit. Next, yung high heat, and then electric arc. Yan. So dito ipapakita natin yung construction ng circuit breaker. So ipapakita muna natin yung pangalan ng kada parts nila. So una, meron yung actuator lever, the actuator mechanism, contacts, then yung terminals, the calibration screw, the bimetallic strip, arc chute, and then we have the solenoid. So actuator lever, used to manually trip and reset the circuit breaker and also indicates the status of the circuit breaker. Itong actuator lever, ito yung makikita natin sa labas. Ito yung ginagamit natin to switch. Ito yung switch ng circuit breaker natin na para i-on and off natin yung circuit. Next is the actuator mechanism. It forces the contact together or apart. Para din siyang actuator lever pero etong actuator mechanism, gumagana siya ng automatic at hindi natin siya pwedeng gamitin manually kasi nasa loob siya ng circuit breaker. So contacts. It emits the load current without excessive heating and must also withstand the heat if the arc produced when interrupting or opening the circuit. So yung contacts, ito yung dinadaanan ng ating load. So kapag naka-receive daw siya ng excessive heating, then nag-start na mag-form ng arc yung metals natin, mag-open yung circuit natin para mag-prevent ng short circuit. So next is yung terminals. Terminals is the component used to electrically connect the circuit breaker to the circuit it's protecting. So dito sa terminals, dito yung connection ng ating wires. Bimetal strip, used to protect circuits from excess current. A coil of wire is used to hit a bimetal strip, which bends and operates a linkage that unlatches a spring-operated contact. This interrupts the circuit and can be reset when the bimetal strip has cooled down. So ito namang bimetal strip natin, nag-ooperate siya na parang yung contacts natin. So kapag naka-receive daw siya ng excess current, tapos yung coil of wire na nakapalubot sa kanya ay uminit. Then magbe-bend siya ngayon, tapos mag-o-open yung ating circuit to prevent na makasira ng ating mga nakasaksak na appliances. Calibration screw. It allows the manufacturer to precisely adjust the trip current of the device after assembly. So ito namang calibration screw. Dito mo i-adjust kung gaano kataas yung parang limiter siya. Kung gaano kataas yung ina-allow niya na current. Then kapag nag-exceed dun sa nilagay mong trip current, then mag-open yung ating circuit. Next is the solenoid or the magnetic coil. This separates contacts rapidly in response to high overcurrents. So dito naman sa solenoid natin or magnetic coils, kapag naka-receive siya ng overcurrents, in a rapid response, open yung ating circuits. Then sa arc shoot, it is a set of insulating barriers on a circuit breaker arranged to confine the arc and prevent it from causing damage. Etong arc shoot naman, pine-prevent niya naman yung damage, hindi dun sa ating circuit. Ito naman, pine-prevent niya yung mga damage dun sa ating components ng circuit breaker. And next slide. So, this is circuit breaker. This is circuit breaker, sometimes referred to as the PV disconnects. They are placed between the solar panels and the inverter in some cases built into the inverter. Short circuit on the part of solar array may produce a high value of current which might damage the inverter or the system as a whole. Before it happens, the DC circuit breaker acts as an automatic switch disconnecting the inverter from the solar array. May also be used as a manual switch for the solar power system or to isolate it. So, kagaya nga nung sinabi ko kanina, so ang main purpose ng circuit breaker natin is to disconnect the circuit kapag, if ever na, maka-receive siya ng overcurrent para maprotektahan yung mga appliances na nakakabit dun sa ating circuit. The next slide. So, we have here the AC circuit breaker. So, kanina yung pinakita nating circuit breaker ay MCB type ng circuit breaker, which stands for miniature circuit breaker. Then yung AC circuit breaker naman natin ipapakita dito is RCBO. So what is RCBO circuit breaker? It stands for residual current operated circuit breaker with overcurrent protection. AC circuit breakers are placed after the inverter. So just like the typical CB, katulad ng pinakita nating circuit breaker kanina, which is an MCB, It acts as an overcurrent protective device due to short circuit and overloading. Unlike MCB breakers, RCBO can sense earth leakage or earth fault currents. It has the capability to trip when somebody touches a live wire. So sa RCBO daw, meron siyang added safety feature na when somebody touches a live wire, mag-open yung ating circuit to prevent any damage dun sa kung sino man yung nakahawak dun sa wire. Next. So, next we have here is the surge protective device. Circuit breakers protect the system from high current. Meanwhile, SPDs protect the system from very brief high voltage or power spike. DC SPD is connected in parallel with the DC circuit breaker and redirects the excessive voltage spike to the ground when detected. SPDs use electronics to monitor the sudden spikes and trigger a trip. Detection range are usually around 1 to 30 microseconds. The most common cause of voltage spike is lightning strikes. So unlike the circuit breaker na pinoprotektahan yung ating system from a very high current, so sa SPD naman, kapag nakadetect siya ng sudden spike, which is usually cause nga daw ng lightning strikes, ito yung dinedetect ng ating SPD para maprotektahan yung ating circuit na usually it is na nangyayari in around 1 to 30 microseconds. So next slide. So we have here the AC SPD naman. So AC SPD, like DC SPDs, it is connected in parallel to the AC circuit breaker. So this serves as a protection against transient voltage, but this time it is on the AC side of the PV system. So wala silang masyadong pinagkaiba. So ang purpose nila pareho lang din naman. Ang pinagkaiba lang nila, itong AC surge protective device naman natin is connected dun nga sa ating AC circuit.
So, time delay switch. So, also called power on delay. A relay device that has a normally on and normally off contacts which is given the desired time interval. So, main purpose niya ay to delay or give enough time for the power surge during abrupt blackouts to settle down. Usually around a minute or so is enough for the power surge to be effective. So, syempre kung nagkaroon ng blackout at pag nag-on ulit yun or nagkaroon ulit ng kuryente, hindi naman yung same value agad yun. Usually may power spike yun or power surge. So, yung power surge na yun, pwedeng makasira yun sa system natin, lalo nga, di ba, grid tie tayo, nakakonect tayo doon. Eh, paano kung naka-on lahat yun, agad-agad? Or better yet, paano kaya kung blackout, tas, merong kuryente, tas blackout, parang paulit-ulit na ganun. Kaya ang easy way para masira yung system mo. So, para natin pinoprotektahan yung system natin doon, ginagamit natin yung time delay switch. So, pag may time delay switch, siya yung mag-disable or siya yung para magiging gateway muna, parang siya muna yung mag-hinto sa system para mag-on at bigyan mo ng enough time yung power para mag-charge or stabilize bago niya padaanin yung power na yun sa system. So, power surge can cause damage to the system whenever there is a sudden jump in current when the power is restored. So, programmable time delay switch, ano naman yung programmable. So, yung programmable naman, pwede mong iset yung time kung kailan siya mag-on or kailan siya mag-off. So, basically, same process lang siya or same reason lang siya ng time delay switch, pero siya pwede mong iset yung specific time ng araw. So, bakit ba ito importante? So, importante to dahil you only need the system to be active at a certain time of the day. So, syempre, solar-powered system to. So, need lang natin siya sa panahon na merong araw. Hindi natin siya need kung meron ng, kung gabi na or hindi naman na kailangan siya. So, programmable time delay switch, yun yung purpose niya. Magsiset lang siya ng specific time kung kailan niya i-allow yung makakonekta yung system sa solar panel or sa AC circuit mo. So, net metering naman.
What is net metering? Net metering allows customer of distribution utilities to install an on-site renewable energy facility not exceeding 100 kilowatts in capacity so they can generate electricity for their own use. So sinasabi dito na pinapayagan daw ng distribution utilities na mag-install yung clients nila ng renewable energy na pero hindi mag-exceed ng 100 kilowatts para magamit nila doon para sa makabawas sila doon sa electric bill nila. So for example, doon sa net metering, lumabas na gumamit kayo, nakapag-produce kayo ng 100 kilowatts para sa buwan na to. Then yung in-install natin na renewable energy, nakapag-produce siya ng 50 kilowatts. So ibabawas natin yung 50 kilowatts na yun doon sa na-produce natin ng 100 kilowatts sa net metering. Then makakatipid na tayo doon ng 50 kilowatts. Next, any electricity generated that is not consumed by the customer is automatically exported to the DU's distribution system. The DU gives a peso credit for the excess electricity received equivalent to the DU's blended generation cost, excluding other generation adjustments, and deducts the credits earned to the customer's electric bill. So sinasabi dito na if ever sumobra yung na-generate ng ating solar panel, mapupunta yun doon sa distribution grid, then tayo pa yung babayaran nila.
Question 2. Is net metering already available in the Philippines? On May 23, 2013, the Energy Regulatory Commission, or ERC, adopted the ERC Resolution 09 Series of 2013, approving the rules of enabling the net metering program for renewable energy. This resolution was published on July 10, 2013 in newspaper of general circulation in the country and took effect 15 days thereafter. Thus, the net metering rules took effect in the Philippines on July 24, 2013. The net metering program is available only to on-grid distribution systems or those connected to the transmission grid. So the short answer is yes, net metering is already in the Philippines. So what benefit will I get if I go into net metering? By generating electricity for our own use, you reduce the amount of electricity you buy from your local DUs. The rate of saving realized on electricity generated for our own use is equivalent to DU's retail rate, consisting of charges for generating, transmission, system loss, distribution subsidies, taxes, and other changes. So basically, pag nag-generate ka sa electricity, parang binabayaran mo na yung DUs mo, o kaya naman parang yung rate ng na-provide ng DUs mo hindi gumagana sa'yo dahil produce ka ng sarili mo ng electricity. You also earn peso credit on any excess electricity exported to the DU equivalent to the DU's blended generation cost, excluding the other generation adjustment. The peso credit earned in this is then used to reduce electric bills. So yun nga, kung ano yung na-generate mong electricity, nakakredit yun sa power bill mo. So either nababawasan niyo yung power bill nyo, o kaya naman ay pag effective yung grid time mo, or pwede mong possible yung magkaroon ng zero bill, o kaya naman wala nang cost yung power bill mo.
Okay, so question number 4. How will my DO monitor the excess energy that my grid-tied setup is exporting towards the grid? The distribution utility may opt to install two unidirectional meters, one to meter the energy you buy from your local DU and the other to meter the energy you export to the DU. The DU may at its option install a single bidirectional meter that can meter both import and export energy if it finds it to be a more economical. The DO may also install a third meter in proximity to your RT facility to meter its total RE generation. The total RE or renewable energy generation shall earn for the host distribution utility RE certificates which the DU can use to comply with its renewable portfolio standards obligation. So paano daw mamamonitor ng DU yung sobra na napoproduce kong kuryente. Tapos yung paano nila mamamonitor yung mapapadala mo kuryente sa grid. So ang DU, ang gagawin niyan is mag-install sila na, kasi ganito yan. So pag yung pag yung ordinary na metro lang yung gagamitin mo, kunyari yung yung traditional lang na metro yung gagamitin mo, yung aling kung saan direction man pumasok yung kuryente kahit sa papunta sa bahay nyo o papalabas ng bahay nyo, ang basa ng metro doon is yung nagamit na kuryente. Ibig sabihin, kahit na sabihin natin meron kang sobra nga na kuryente na na-produce, pag dumaan sa metrong ordinaryo, pakakount yun as nagamit na kuryente mo. So, lugi ka. Kumbaga, parang napamahal ka pa kasi yung nabasa na kuryente ng metro mo is counted as yung nagamit na kuryente mo. Hindi siya na-counted na sobra. So, yun yung disadvantage ng gumamit ng ordinaryo na metro. Pero yung DU is i-recommend nila na mag-installan sila ng dalawang unidirectional meters. Yung isa, yung metro na magka-count nung nagamit mong kuryente o yung nabay mo mula dun sa distribution utility mo. And yung isang metro naman, ito yung magme-measure nung na-export mo o yung sobra na kuryente na na-produce mo. So, tigisa yung i-install ng video mo. Isa dun sa papasok na kuryente, isa dun sa papalabas. So, para hindi malilito yung isang metro na kung alin yung lumalabas o alin yung pumapasok. So, meron din option yung DU na ang gamitin, yung isa na lang, yung isang metro na lang. Pero, ang kakaibahan nun sa ordinary metro is nadidistinguish niya kung yung kuryente is pumapasok dun sa bahay nyo o lumalabas dun sa bahay nyo. So, pag yung pumapasok na kuryente sa bahay nyo, yun yung nagagamit nyo, yung binibili mula sa grid. Yun naman lumalabas, yun yung ibebenta nyo. Pero i-install lang yun nung DU nyo kapag yung pag mas economical siya. So, yun. So, pwede rin mag-install yung DU nyo ng pangatlong metro na malapit dun sa RE facility nyo. In this case, yung mga solar panel nyo nga. So, yun. So, pwede silang mag-install ng isa pang metro doon para mamomonitor naman nun yung total na napoproduce na electricity ng RE facility. So, para naman yun din sa solar panels. No? So, hiwalay yung metro nung grid sa kanong solar panels. So, yun. And then, question number 5, who are qualified to participate in the net metering program? yung customers who are in good credit standing in the payment of their electrical bills, so there you are qualified to participate in the net metering program for renewable energy. These customers are referred to in the rules as qualified end users. So, sino daw yung mga pwede mag-net metering? Yung mga walang utang sa distribution utility nila. Yun. Yun yung mga pwede. Or yung mga in good terms, kumbaga. Yun. So, ang tawag sa mga users na to is qualified end users. So, qualified. So, pwede. Sabihin. So, or QE. So, ayun. So, that's all about the net metering program.
So, ano naman
Now,
consequences of not applying for net metering? So, in the case that solar power system is being installed and doesn't apply for net metering, any excess energy that is being fed to the grid will be billed to the customer. Example is when the solar array is rated at 5 kilowatts and the load consumption is only 4 kilowatts. The system will have an excess of 1 kilowatt which will be sent to the grid. This excess energy will pass through the meter, hence will be billed to the owner. So as previously mentioned, kapag may excess ka o na-generate ka na power na excess power na napunta sa grid mo or dumaan sa metro mo na unidirectional lang o isang direction lang yung kinakount niya, papatong pa yun sa bill mo imbis na magbawas. So, paano prevent yun? So, pwede mong prevent yun sa pag-install ng 2 unidirectional na submeter o kaya naman isang bidirectional na submeter. Otherwise, pwede kang gumamit ng inverters with limiters na. So other than net metering, is there any other way we can benefit from solar power system grid tie without producing excess energy during the day and yet will not pay for it? So yun nga, meron maparaan, yun nga, yung inverters with limiters. This type of inverter is capable of limiting the power output of the system when it detects the maximum power that the system can provide without sending excess power to the grid. So, patulad na mention ko sa last time, itong power inverters with limiters, alam niya kung ilan lang yung power na ginagamit mo. Di ba nga yung excess ang pag excess yun, napupunta sa grid mo, yun yung parang dumadagdag sa bill mo pag di ka naka-net metered na submeter. Yung inverters, siya yung nag-limit kung ilan lang yung kaya mo. So basically, i-disable niya yung excess. Kinukuha niya lang or pinoproduce niya lang yung kailangan ng circuit mo or ng load mo. Kung hindi niya kailangan yon, i-limit niya yon or i-prevent niya yon para lumabas sa distribution utility grid mo. So walang magkakaroon ng excess power or excess bill na dapat hindi mo naman binabayaran. So wire types na.
So, ito yung mga ginagamit na wires sa pag-install na grid tie solar system. So, una, meron tayong thermoplastic wire or TWE. Then, upgrade thermoplastic heat resistant wire or THWE. Thermoplastic high heat resistant nylon coated or yung THHN. Then, thermoplastic heat and water resistant THWN and thermoplastic heat and water resistant nylon coated or yung THHN2. So, upgraded na THHN. Then, last is yung PV wire. Okay, so thermoplastic wires or yung TW. So thermoplastic, ibig sabihin, resistant siya sa sunog, thermoplastic or sa high heat. Yung advantage na. Then, resistant din siya sa moisture. So sabihin natin, may wire sa bubong mo kasi nakakabit ng solar. So hindi siya maapektuhan ng moisture or ng tubig. Okay? THW or yung may dagdag na heat resistance. So, upgraded version siya ng TW, besides sa moisture resistance siya, mas mataas yung resistance niya sa heat and makakaiwas pa siya sa heat. Thermoplastic high heat resistant and nylon coated. So, design to for specific insulation material temperature rating and position cues. Suitable for dry and damp application. So nylon coated. So PHHN. So suitable siya sa ah, mga dry or yung sobrang maiinit na lugar. So sobrang tuyulog syempre. And yung damp. So yung laging umiilang. So yun. So yung nylon coating niya, ito yung nagpapatibay sa kanya para makapag-withstand siya ng harsh environments. The next, PHWN slash PHHN-2. So, ito yung upgraded. So, ito yung pinakamataas dito sa ano na to. Thermoplastic heat and water resistant or thermoplastic heat and water resistant and nylon coated. So, yung PHWN is similar daw sa PHHN except it is water resistant. Adding the W into the acronym. So, yung W stands for water resistant. PHWN is rated for up to 167 degree Fahrenheit or 75 degree in wet environments. But its successor, PHWN-2, is rated for 90 degrees. So, mamaya makikita niyo yung table kung saan to is rated for 90 degree Celsius in both wet and dry environments. Historically, PHHN and PHWN were separate wires. But now you typically find their capabilities combined in the PHWN-2 design. So ito nga yung pinag-combine. So dati daw hiwalay yung ito and then yung itong PHHN. So hiwalay yan. So ngayon meron ng bago na pinagsama yung advantage ng dalawang type ng wire. So, ayan. So, recap nung kung ano yung sabihin nung acronym. So, pag T, thermoplastic, insulated. Pag naman sinabing H, heat resistant. Pag naman H, double H, yung sabihin nun, mas mataas yung tolerance niya sa init kumpara dun sa H lang. Pag naman N, nylon coated, and pag W for water resistance. So pag yung hinahanap mo yung the best na wire, ang gagamitin mo dyan is yung PV wires. So exclusive to dun sa solar panel. So ito yung design talaga para gamitin sa isang solar panel system. So this type is an exclusive kind of wire. So it's rated for PV applications exclusive. These cables behave extremely well in very hot temperatures and other harsh environmental conditions. So compared sa mga nakaraang wires, so sobrang resilient nito pagdating sa harsh environment. So sa very hot and very cold. Its special characteristics compared to other wire is its insulation and outer sheet, which is made up of XLPE or EPR. So ano yung mga yan? XLPE is an acronym for cross-linked polyethylene. Cross-linked X. Cross-linked. Ibig sabihin nun, yung XLPE daw is a thermosetting polymer, meaning that the material or yung polyethylene is cured under heat. And in that process, forms bonds in all directions, forming a three-dimensional matrix. EPR means ethylene propylene rubber. So, ito daw cross-linked polyethylene. So, especially treated siya para mag-provide siya ng extra resilience sa harsh conditions. So, ito talaga yung the best na wire pag mag-i-install ng solar power system. So, yung PV wires. Pero, ito may kamahalan. Pero kung gusto mo talaga ng pang matibayan at pang matagalan, PV wires. So, ito yung, ano niya, yung itsura ng PV wire. So, yung dulo. Ito yung tin copper. So, bakit tin copper? So, meron siyang coating na tin. So, yun. So, ito yung, so, dito sa PV wire, dalawang insulation niya. isang insulation sa loob, yung nakadikit sa copper, and ito namang outer sheet. So, this is to ensure na talagang sobrang tibay ng TV wires na gagamitin. So, ayan. So, ito yung gauge o yung sukat. So, ito yung American standard. So, kung titingnan nyo mabuti, mas papaliit yung number ng gauge, papataba yung wire. So, alam natin na pag mas mataba yung wire, less resistant yung wire. So, mas madaming current na magpo-flow doon. So, the lower the gauge, the better. Kasi nga, mas makakapal. So, ito yung pinaka-sukatan niya. So, ayan. So, ito yung different na gauge na wire na commonly used. 14 yung pinakamatipis and 8/0 yung pinakamakapal. Okay, so ito yung mga tables. So, ito yung list ng tables natin. So, isa-isahin na lang natin yan dito sa mga slides. So, first, we have the 310, 250, 360. So, ginagamit to sa para ma-measure yung capacity ng wire at an ambient temperature of 30 degrees Celsius. So, ito yung sukat ng wires, ito yung types, ito yung temperature. So, nakailalim dito sa mga temperature kung aling type ng wire yung ginagamit. So, ito yung adjustment pag hindi 30 degrees Celsius yung ambient temperature. So, ito yung gagamitin na adjustment. So, ito yung multiplier. So, ayan. Then next, ito yung wire ampacity ulit, pero nakafocus na siya sa copper only. So, wala yung aluminum portion. Then next, ito yung adjustment na gagamitin dun sa distance na cables dun sa sahig ng group natin. So, kung yung elevation, kumbaga, gano'n siya kalapit dun sa pinakabubong. Then, ito yung sa kung ilang conductors, kung ilan yung linya. Pero since dalawa lang naman yung usually yung linya, so disregard na natin. So, ito naman yung sa cross-sectional area. So, ilan yung circular wheels ng kada gauge. So, ito naman yung sa circuit breakers. So, ito yung steps kung anong tamang ang size ng conductor na gagamitin natin sa ating solar panel system. So, number 1 is yung to look for the IOC rating of the PV cell. Then, i-multiply mo yon sa dalawang safety factors, yung irradiance and effectiveness duty. Then, next is yung nakuha mo na sagot, i-repair mo dun sa 310.15 D16 na table para dun sa size ng wire. The number 4, i-repair ka naman sa 310.15 D28 for the ampacity correction. Kasi nga, hindi 30 degrees Celsius yung ambient temperature sa Philippines. So, may adjustment. So, number 5, repair on table 310.15 D3C for ambient temperature adjustment due to conduit or wire distance from the earth. Yun yung sinabi ko kanina na kung gaano kalayo yung wire dun sa bubungan. Then, number 6, repair on table 310.15 D3A for adjustment due to more than 3 wires inside the conduit. So, since hindi naman, dalawa lang naman yung ginagamit natin conduits in line, i-disregard na natin yung number 6. Then 7, find the adjustment due to voltage drop. Then lastly, the value obtained in the last step will be the basis for the size of work to be used in the PV system. So, itong steps na to, ito yung gagamitin natin mamaya dun sa pagsa-size ng conductor dun sa i-install natin um, PV system. So, mamaya natin gagamitin yan. So, next, we have a table here. So, ito na yung parang shortcut dun sa mga nakaraang table. So, ito na yung, dito ka lang titingin para automatic malaman mo kung ano yung dapat na wire o yung gauge ng wire na dapat mo gamitin. So, pero importante pa rin na malaman mo kung ano yung step by step para for accuracy. So, yun. Kailangan alam mo yung step by step as a engineer.
Inverter sizing. For the inverter to fit the system, its power rating must be approximately equal to the power rating of the solar arrays, or maybe a bit greater of around 10% to 20%. So therefore, if your solar system is rated at 2000 watts, you'll need a solar inverter that is about 2000 watts. An inverter that is way below the power rating of the solar arrays cannot maximize the power that the solar arrays are capable of. So sinasabi dito na kung ang solar panels daw natin is rated at 2000 watts, kailangan din daw natin ng inverter na tumatanggap ng 2000 watts dahil kapag sumobra yung pinoproduce ng ating solar panels, for example, nag-produce ng 3000 watts, then yung inverter natin tumatanggap lang ng 2000 watts, masasayang yung power na pinoproduce ng ating panels. So if the inverter kung yung inverter naman daw is way above the power rating of solar arrays, it will have a noticeable drop in efficiency. So kung mas mataas naman daw yung kayang tanggapin ng ating inverter kaysa dun sa pinoproduce ng solar arrays natin, bababa daw yung efficiency ng ating inverter. So for example, nagpo-produce ang ating solar panel ng 900 watts. So sinabi nga dito na pag sizing tayo ng inverter, pwede siyang greater ng 10% or 20%. So yung 900 watts, i-multiply natin ng 10%, which is yung 1.1, then lalabas yung 990 watts. So kailangan natin ng 990 watts na inverter. So wala namang exact na inverter na 990 watts. So ang gagamitin nating inverter ay yung merong grade na 100 kilowatts.
Okay, so dito naman sa DC, sa pagsa-size naman ng circuit breakers, first thing to consider in sizing a CD or circuit breaker for sa system natin is yung ruling ng Philippine Electric Code na nagsasabi na yung PV circuit current is continuous. Thereby, the minimum OCPD rating is 125% of the maximum current. So, according to PEC 2017, Article 6.90.2.2b and Article 6.90.2.3. So, yun. So, ibig sabihin, yung daw gagamitin yung minimum na OCPD rating natin, which is yung over current protected device, ito nga yung circuit breaker. Yung minimum rating dapat na gagamitin natin is 125% of the maximum current ng kumaanong current sa ating conductors. So therefore, in reference to the problem in conductor sizing, so on the DC side, the maximum current multiplied by 125% would give us the approximated rated DC current. So naman sa AC side, the inverted rating divided by the rated voltage would give us the approximate rated AC current. So, ayun. So, pareho lang na i-multiply natin ng 125%. So, sa SPG sizing naman, so very simple to. So, yung pagsasizing daw ng SPD, yun daw, yung C-rating ng gagamit na SPD is kailangan i-match niya yung system voltage na or i-match or pwede na mas mataas ng 15% to 20%. So, etong 15 to 20 15 to 25% na to, isa tong parang safety measure para tumagal yung buhay ng ating SPD. So, ito yung specs na makikita natin sa ating SPD. So, IN, ito yung nominal discharge current. Yung IMAX, yung maximum discharge current. UC, maximum continuous operating voltage or yung MCOV. UE, yung voltage protection rating or VPR or surge voltage rating or SVR or clamping voltage rating. So, ayan. So, yun lang yung tamang pag-mention ng SPD.
So, solar panel orientation. On those countries located at the northern hemisphere, solar panels should be facing south for maximum sunlight, while in the southern hemisphere, it should face north. So, parang compensate nila yung kung saan sila sa mundo by facing the solar panels to the equator o kung saan dumadaan yung araw para i-maximize nila yung amount of sunlight saka i-maximize nila yung amount of time na dumadaan yung araw sa solar panels, yung light ng araw sa solar panels. Since the Philippines is above the equator, it belongs to the northern hemisphere. Thus, yung solar panel natin, iharap natin sa south direction for maximum efficiency. A general rule for optimal annual energy production is to set the solar panel tilt angle equal to the geographical latitude. Essentially, the closer the solar panel is located to the equator, the more the panel should be pointing straight up. The closer the panel is to the poles, the more they should tilt towards the equator. Therefore, in Philippines, the solar panel tilt should be 12 to 14%. So, for example naman tayo yung zero BL computation. So, sabihin natin may monthly average kilowatt hour tayo na 300 kilowatt hour per month. So, convert natin yung sa daily usage na 30 days. So, 300 divided by 30, 10 kilowatt hour per day. Ngayon, convert natin yun sa watt hour lang. So, magiging 10,000 watt hour per day. Sa Pilipinas, merong peak sun hours na 5 hours per day. Pero depende rin kung saan ka nakalocate sa Philippines. So, dito naman tayo usually nakalocate sa dito naman tayo lahat nakalocate. So, sabihin natin 5 hours per day yun. Or 5 hours to 5.5 hours. So, yun ang magiging value natin, 5 hours per day. Ngayon, yung 10,000 watt hour per day na yun, i-divide natin siya sa 5 hours per day. So, magkakaroon lang tayo ng 2,000 watts. Ngayon, meron pang tinatawag na zero bill insurance na multiply niya yung watts natin na 1.1. So, magiging 2,000 times 2,200 watts. So, di-divide natin siya sa number ng watts sa panel natin. So, 2,200 divided by 300 watts, magkakaroon tayo 7.33. Dahil wala namang 0.33 na solar panel, i-consider din natin yun na 8 solar panels. Di bali ng mas sobra, wag lang kukulangin. So, yan. Ngayon, recap natin yung mga need na computation. So, meron tayong wire sizing, inverter sizing, DC-AC circuit breaker sizing, saka SPD sizing, saka zero bill computation. All computation will be done in the next part. So, yun na yung mismo kami magde-design ng solar panel grid type na system. So, dito tayo sa grid type solar system installation. So, magde-design po kami ng solar system namin para kay Sir Dipasupil here. So ito po yung front view niya from the right side. Tapos ito po yung front view from the left side. Tapos ito yung left side po ng bahay niya. Tapos sa bandang roof po, meron po parang small window doon. Doon po yung barak namin na idaan yung wire kung saan galing yung solar panels. So ito yung illustration ko kung ano yung rough sketch or rough drawing ng bahay po na pag-install namin. So nagbigay kami ng or nag-take kami ng measurements. So yan po yung 7 meters siya. 7 meters each side. So solar panel orientation. So ito yung bubong nila from Google Maps. So ito yung orientation niya sa sa compass. Pero 'di ba sinabi namin kanina na sa solar panel orientation dapat naka-face siya sa south. This time meron kaming reason kung bakit hindi namin i-follow yung daan na 'yon. So, of course, dito magdadaan yung araw pag ganon. Pero kung notice nyo dito, meron ditong mga puno na pwede pong mag-grow. Pero pwede po siyang drop ng branch or makasira sa solar panel kung dito namin nilalagay yung solar panel. So, pwede mag-drop siya ng branch or mabagsakan ng punong parte ng puno. Kaya naman mismong puno pa yung bumagsak. So, naman hindi po. So, decide namin na since magra-rise naman dito yung araw, lagay na lang namin dito yung solar panel. Pero, lagay namin ng tilt para ma-compensate niya yung positioning niya. So, ito yung illustration ulit pero breakdown namin sa dati para mas madaling makita kung saan dadaan yung wire. So, ito nakatilt dapat to. So, ito yung pagdadaanan ng wire namin. So, yung mention ka nga na window sa roof nila, doon dadaan yung wire na galing sa solar panel. Tapos nakalagay na dyan yung kung ilang metro yung wire. Ngayon, ito naman yung from inside. Dahil nakapasok na dito yung wire, dito magsistart yung wire na yun bago pumunta dito. So, from here, 3.25 meters, 1.5, 3 meters, 1.5, saka 1.3 hanggang sa kitchen niya. Tapos ito naman yung padera ng kitchen niya. So, yun yung 3 tapos 1.5. So, from 1.5 here, may syempre pababa pa yun para katabi nyo na lang yung control panel ng AC. So, 1.4 meters. Kung i-add mo na yung lahat, dapat magkakaroon ng 24.7 meters. Pero, lalagyan na namin ng allowance na gagawin na po namin na 25.5 meters. So, zero bill computation. So, ito yung past bills ni Sir Oliver in this March and April. So, 79 watts dito, tapos 86 watts dito. Ngayon, i-divide namin yung sa 2. So, meron siyang average na 82.5 kilowatt hour per month. Ngayon, same process lang din ang ginawa natin yung example kanina. Divide by 30, 2.75 kilowatt hour per day. Tapos gagawin natin watt hour lang. So, 2,750 watt hour per day. Tapos yung same lang din naman siya na 5 hours ng annual na sun hour dun sa kanila. So, divide by 5. So, 550 watts. Tapos merong zero bill assurance. Multiply natin siya sa 1.1. So, maging 605 watts. Ngayon, dito namin na-decide na yung 300 watts hindi yan enough. So, gagawin namin ay 350 watts. I-divide natin yun sa 605. So, 605 divided by 350 watts, 1.73 or 2 solar panels.
We decided na ang gamitin ng solar panel is yung Dina solar power panel. So, like I mentioned before, yung green na solar power is ang 40 niya is yung durability and yung longevity ng solar panel na to. So, considering that the our home is into 20 harsh environment, also hot. So, ito yung napili namin na solar panel since matibay siya and long-lasting na rin. And also affordable. So, ito yung specs niya. Gagamitin natin later sa ating calculation. So, dimensions, ito. 190 times 160 times 992 times 40 meters. So, length, width, and yung thickness. Then, yung bigat niya, meron siyang 30 kilograms. Then, 2 times 26 kilograms times 2. So, meron siyang 52 kilograms na ilalagay namin sa bubong. Plus pa yung components. So, pwede, plus pa yung mga railing. So, meron siyang around na sabihin natin 65 kilograms dun sa bubungan. Then yung cells, anong klase yung structure niya? So, monocrystalline. Then, ilang cells? Yung isang panel, meron 72. Yung rated watts ng isang solar panel na 350 watts. So, dalawa yung gagamitin natin. So, meron siyang total na 700 watts. And yung BMP or yung max power voltage, 38.7. Max power current for IMP, which is 9.04 amps. Open circuit voltage at 47 volts. So, pag walang nakakonect. So, this is pag walang load. Short circuit current na 9.6. And yung max system voltage na 1.5 volts. So, ito yung temperature coefficient niya na 44 degrees Celsius. So, sa wire sizing, so, ang susundan natin steps is yung kanina na 8. So, for this connection, we'll be using 8 2 times 800 watts in a solar panel. So, meron tayong 700 watts in total na power rating ng ating solar panel. So, nakakonect siya in series. So, meron siya ngayon short circuit current of 9.6 amps. Balik tayo dito. So, ayun siya. ISC is 9.6. So, since series siya, hindi natin siya i-multiply by 2. So, ang mababago lang is yung voltage. So, hindi natin papakilaman 9.6. So, ang nangyayari, i-multiply natin yung 9.6 dun sa dalawang factors na continuous duty and yung irradiance. So, ito, yung dalawang factors na yan is yung 1.25 na dalawa na to, which give 9.6 times 1.25 times 1.25, which give us an answer of 15 amps. So, ito yung current na IPV rating natin. So, current, not exactly yung current na electric current. So, current, ito muna for now. So, referring to table 310.15 to 16, so, using ayan, no? So, using a 14 gauge, ito yung sabi na. So, number 14, THWN/2 wire, ang capacity na 25 amps is allowed. So, dahil 15 amps lang, pwede tayong gumamit ng 25 amps. So, asan yun? So, ito siya, yung 14. Ito yung coefficient niya. Ito yung gagamitin kasi natin. THHN o THWN/-2. So, kung titignan natin, kung sisipatin natin sa 14 gauge, ito siya, 25. Ito yung pwede natin gamitin na conductor. Pero, for allowance, ang gagamitin natin is yung number 12. So, ano yung capacity nun? 30 amps. So, ayun siya, 12 amps. So, meron siyang capacity na 30 amps. Ayan. Okay, so meron tayong IPV rating na 30 amps. So, ayun nga, sabi nga ano, there will be corrections, however, due to the higher ambient temperature in the Philippines, which is 37 degrees Celsius compared to other countries. So, paano natin i-adjust yan? Re-refer tayo ngayon sa table 310.50 to 8 na. So, with an adjustment of 91% from the original value at temperatures between 36 degrees Celsius and 40 degrees Celsius. That is table. So, ayun. So, alam natin na yung THHN wire na gagamitin natin is magpo-fall sa 90 degrees Celsius dito sa kabila. So, ito yung 37 degrees Celsius na dito siya nakababila, yung ambient temperature natin. So, sisipatin natin, no? Ito yung katapat niya. So, ito, sa 90 nakatapat. So, 0.91. I-multiply natin yun, isa nakuha natin, IPP rating na 30 amps. Then, pag multiply natin ito, 0.91 or 91%, meron na yun tayo, 27.3 amps. So, hindi pa to dito magtatapos yung adjustment. So, makaka-apekto din yung init ng bubong natin dun sa wire na gagamitin natin. So, the wire exposed to the sun at the position 3.5 inches. So, iaangat natin yung wires natin na ilalagay natin sa bubong. So, nakaposition siya 3.5 inches above the roof floor. To minimize the heat affecting the current flow within the wire. So, alam natin yung bubong is mainit siya pag nasikatan ng araw, uminit. So, pwede yung maka-apekto sa wire natin. So, iaangat natin. So, ang magiging temperature adder lang natin would be 17 degrees Celsius. So, refer tayo sa table 310.50 P3C. So, ito yung sa adjustment ng sarili natin. So, 3.5 yung adjustment natin taas. So, yung other natin, ito yung 17 degrees Celsius. So, i-add natin yung 17 degrees Celsius ngayon sa ambient temperature natin na 37 degrees Celsius. Meron tayo ngayon 54 degrees Celsius. Yun yung init. Again, since ito yung bago nating temperature, so magre-refer ulit tayo sa 310.50 dito eh. So, i-adjust na ngayon natin yung ang positive value to 76%. So, ayan. So, i-multiply natin yung nakuha natin ang positive value na nakuha natin to 76%, which will give us an answer of 20.75 amps. So, ayan. Siya. 51 to 55. Ito siya under 90 degree. So, multiply niya is 0.76. So, ito lang ang positive ng wire na makukuha natin from a number 12 THHN /THWN-2 na wire. So, yun lang nakuha natin ang positive. So, ayun siya. Ayun, 30. So, yung ang positive value ng wire natin is 20.75 amperes. Going for the number 12 conductor is good enough since the final and positive is larger than the original. So, ayun, ito yung original natin. So, itong original, multiply na natin dun sa sa dalawang factors natin na irradiance and continuous UV. So, mas malaki yung final value natin kaysa dun sa original value natin. But there will be another adjustment due to the voltage drop. So, ito yung voltage drop natin. So, paano i-measure yan? Voltage drop is equals to 2 times IMP times R. Paano natin makukuha yung resistance? Yung coefficient natin na K times length divided by area. So, paano natin makukuha yung ah, yung rating ng ating voltage drop. So, yung voltage drop divided by BMP times 100. So, the Trina solar panel has a maximum current of 9.20, and the measured distance of the connection from the solar panels to the system is 24.7 meters as the previously mentioned. Pero ang gagamitin natin para mipasobra dun sa length ng ating conductor is magpapasobra tayo magiging 25.5 meters of conductor. So for the cross-sectional area of the wire, with number 12, meron siyang circular views ng 6,530. So ayan, kompleto na yung values natin. Isa-substitute na yun natin. Pero ito yung note. The calculated voltage drop should be less than 3% for optimization. So ito yung ano natin, yung goal natin. Kailangan mas bababa. So yung K, ang ibig sabihin ng K, ito yung direct current constant. So ano yung K natin na yun? So for copper wire, ang K natin is 12.9 ohms. Ito yung multiplier natin. Ito yung coefficient natin. So ito na. Again, ito yung table ng cross-sectional area natin. So, ayun yung number 12 na gagamitin natin. Pero, 6530 na circular phase. So, wire sizing. So, voltage drop equals to 2 times yung IMP natin, which is 9.04 times 12.9 ohms yung ano natin, multiplier, times 25.5 meters. Ito yung length ng wire natin over yung cross-sectional area na 6,530 circular mil. So, meron na tayo makukuha na voltage drop na 0.91. So, ano yung percentage ng voltage drop natin? So, yung 0.91 na nakuha natin, i-divide natin sa BMP natin, which is 38.7 times 100. So, ano yung sagot? Meron tayong 2.35% ng voltage drop. So, in conclusion, so, ang sabi natin kanina, kailangan yung voltage drop natin is mas mababa sa 3%. Therefore, yung number 12 na conductor is suitable for the system. So, pwede natin gamitin kasi yung voltage drop natin is 2.35% lang. So, pwede yung number 12. Pero, we're going for optimization here. So, hindi namin actually gagamitin yung number 12 na wire. So, ano yung gagamitin namin? Yung number 10. Para, for safety, kasi nga, yung 2.35, masyado siyang malapit sa 3%. So, we will be going for a larger wire na number 10. For the sake of safety and for future renovations. So, pag naisipan namin na expand pa ng solar system namin, hindi na kami mahihirapan na mag-i-adjust pa yung wire natin kasi in the beginning, gumamit na kami ng mas makapal na wire. Okay, so since we changed from number 12 to number 10, ito yung calculations natin. So, ito yung voltage drop. So, same procedure, pinalitan lang natin tong area, which is 10,380 circular meters, which gives us a voltage drop of 0.57. So, 0.57 divided by the maximum voltage times 100 gives us 1.48%. Okay? So, ayan. So, ito yung bagong IPD natin. So, 40 times 0.91. Naging 40 siya. Naging 40 siya kasi nagbago tayo ng wire. From number 12 to number 10, so gagamit tayo ng 40. So, ayan. 40 times 0.91 will give us 36.4 amps. Then, magbabago ulit tayo. I-multiply natin itong answer to 0.76. Dahil dun sa cable to roof distance. So, 0.76 times 36.4 will give us a short circuit current of 27.66 amps. Therefore, the final ampacity of our wire is 27.66 amps. So, ayun na, malaking binaba kasi nga dahil sa hot climate ng ating bansa. From 40, naging 27.66 na lang yung ampacity ng ating wire. Okay. So, ayun yung ating wire sizing. So, punta naman tayo ngayon sa inverter sizing. So, binanggit kanina, sa paggamit ng tamang inverter, yung power rating ng ating inverter should be equal to that of the solar panel. Or pwede namang tumaas ng 15% to 21%. So, since yung wattage ng ating solar panel is 700 watts, ang gagamitin natin, syempre, is 700 watts din. Grid tie inverter. So, ano yung natin din namin brand? Yeah. Solis Mini 740. So, ito yung specs niya. Ayan. So, maliit lang siya. Meron siyang 310 times 372 times 160 millimeters na dimensions. So, gano'n siya kabigat? 7.4 kilograms. So, sabi ko nga kanina, ang Solis, very lightweight and compact. So, yung maximum efficiency niya is 97.2%. So, pretty good kasi nasa 90 plus. So, yung max DC input niya is 900 watts. Then, yung max input niya is 600 volts. Yung imax input naman niya, 11 amps. Yung rated grid voltage niya is 220. Short circuit current of 17.2 amps. Maximum AC output na 800 watts and rated AC output na 700 watts and the maximum output current na 4.4 amps. So, ayan yung specs ng Solis. In the previous slides, the maximum current that we have calculated is 50 amps. So, ito. According to the Philippine Electric Code of 2017, it is required for overcurrent protective device to have a rating of 125% of the maximum current. So, ibig sabihin lang yan, i-multiply natin yung maximum current natin to 1.25. So, pag i-multiply natin yan, magkakaroon tayo na 18.75 amps. So, yung calculated minimum rating natin is 18.75, meaning we can use a 20 circuit breaker. However, considering the narrow gap between the intended CD rating and the calculated value, we use a 25 amps circuit breaker to prevent the system from failure. So again, sobrang lapit ng value yung minimum rating natin sa 20 amps na gagamitin natin. So instead, we will be using a 25 amps for allowance. So again, it's all about the optimization. Kailangan the higher, the better. And sa, ano naman tayo sa AC. Sa AC side naman tayo. So for the AC circuit breaker, since the power rating of the inverter is 700 watts and the system voltage is 220, you can find the power formula, you can use the power formula to get the current, which is power over voltage na 700 divided by 220 will give us 3.18 amps. So, i-multiply natin from 3.18 amps to 1.25 base dun sa rules na sinabi kanina. and we will get 3.98 or 4 amps. But since using 15 to 15 amps circuit breaker would be too much, we can use a 10 amps RCBO for the AC side. So, for the AC side to. So, compared to sa DC side, mas malaki yung kailangan. Okay, dito naman tayo sa SPB. So, sa yung voltage rating naman ng kailangan natin DC surge protection device should be 15% to 25% more of the combined voltage of the solar panels. In this case, yung dalawang solar panels natin is connected in series. Magkaroon yun siya ng 77.4 volts. So, dalawang in series yun na naka 38.7 volts. So, pag pinag-plus mo siya, ito is ulit. And then, i-multiply mo yun sa 1.20. So, magkakaroon tayo na 92.88 volts. Therefore, the intended SPB for the system should have a rated voltage of 110 volts. So, ito yung gagamitin natin rating ng ating SPB. So, paano naman sa AC SPB? We will be following the same procedure by multiplying the system voltage 220 volts by 1.20. So, same lang din ang multiplier. So, ano yung system voltage natin? Ito. 220 volts. 220 times 1.2 will give us a 264 volts na AC SPB. So, ito yung kailangan natin na SPB sa AC side. Pero, since wala naman saktong 264 volts na SPB, ang gagamitin natin, yung pinakamalapit, is 300 volts. So, allowance na rin. So, for the circuit diagram, so again, we have two 350 watt solar panel connected in series, which give a 700 watts solar array. Yung ngayon solar array natin is naka-connect siya in series dito sa ating circuit breaker na merong 25 amps. So ito ngayon DC circuit breaker is na-connect siya ng parallel dito sa DC SPB. Okay, so itong DC circuit breaker natin is nadali niya, nakakonekta ngayon siya in series dito sa ating Solis inverter. So itong Solis inverter na to, itatransform niya yung ating DC signal from dito sa ating array into AC. So yung AC ngayon na yan, ibabato niya dito. So, yan. Meron siyang neutral, line, and ground wires. So ito nga palang ground wires is nakakonect siya sa nakakonekta siya in parallel dito sa ating array, sa inverter, sa ating AC-SPB, and dito sa ating AC-RDO. Na ngayon ay nakakonekta dito sa ating panel board. Okay? So, again, dito sa ating inverter, nakakonekta siya ngayon in series dito sa ating dalawang time delay switch. Ito yung programmable, ito yung ordinary na time delay switch lang. Okay? So, nakakonekta siya in series. So, ayan. And then, ito yung time delay switch is kukonekta ngayon siya in series dito sa ating AC-SPB. And ito naman AC RCBO natin is nakakonekta in parallel dito sa ating AC-SPB. Okay. So, finally, dito sa ating AC RCBO, dito sa sa circuit breaker sa AC side, nakakonekta siya ngayon dito sa ating panel board, which is, ito nga yung panel board is nakakonekta sa ating grid. So again, ito naman tong green line na to, ito yung connect dito sa ating ground. So ito yung ating diagram for the circuit, ating grid-tie solar power system. So again, to recap all of our computations, yung average monthly power bill natin based sa 2 buwan na electric bills is the meron tayong 82.5 kilowatt hours per month. So, yung nagagamit namin per month. And yung rating natin, dalawa yung panels na meron tayong 700 watts. Monocrystalline for maximum efficiency. So, yung grid type PV inverter natin, meron din siyang 700 watt to match the power rating of our solar array. So, yung ating ginamit na Solis PV inverter is meron siyang, nagpo-produce siya ng pure sine wave signal. Okay. Yung wire length. Yung wire length namin na na-measure is 24.7 meters. Pero for allowance, gumamit kami ng 25.5 meters na haba ng wire. So, yung wire size namin, number 10, again, THHN/THWN/-2 for better quality. So, alam natin na ito yung the best quality. Second best in quality. So, pumapangalawa lang ito dun sa PV wire. Number of wires. So, dalawang live wires and one ground wire. Then, sa DC circuit breaker natin, meron tayong 25 amps. And dun sa ating AC circuit breaker or yung RCBO natin, 10 amps. DC SPD, 110 volts, and AC SPD, 300 volts. Okay. So, ito yung mga kailangan natin na components para ma-build itong grid-tie power system to ensure na magsi-zero bill yung aming billing. So, this is for a zero billing grid-tie solar power system. Okay, so I guess that wraps up our presentation for our grid-tie solar installation at our residence. Again, I am Mark Oliver Dipasuki.
I'm John Martin Misha.
I'm Justin Medina.
And thank you for listening. God bless.